Afternoon. Thanks for coming by. Second last session on a Thursday, so appreciate you coming by to see this talk. So myself and two colleagues, Penny and Ori, are going to take you through a whirlwind tour of where and how to store your stuff on GCP. So we know that as you approach a cloud platform for the first time, sometimes coming from on-premises, there's a very wide range of options for you in terms of choices about where to store your data in the cloud. So what we want to do is sort of give a high-level overview of how to translate some of what you might have seen on premises to what that looks like in the cloud, and then an overview of some of the great services we have in the cloud, not just from its kind of capability point of view, but also try and help route you from a use case point of view, right? Storage and databases nearly always used as part of a solution, so just help you think about like which solution and which problems do you have for the business and which storage solution might best work for that. Please give us your feedback, very much appreciated. So please take the time to give us feedback and help us improve these sessions going forward. Okay, so three parts really to this talk. The first part, I'll just talk through sort of a brief history of storage and the options and how the industry has evolved over, frankly, the last kind of 30 years and what's that meant for the cloud. I'll go through then some of the particular options around storage, and then my colleagues will run through the database options and a demo. First, maybe just a couple of words about myself. So Dave Nettleton, I lead the product management team for storage for GCP. I've been there for about 3 years. I work out of Seattle. Before that, I was at Microsoft for about 14 years, so worked with a lot of enterprise customers on storage, database, and big data needs in that time. My accent's probably given me away from a little further up north from here originally before that. So let's just do a little bit of a sort of brief history of storage and databases. So on the storage side, if we go back far enough, the way that you got storage for computers was it was physically attached to the computer, right? So this is direct attached storage for local data on the machine, the application, the file system, the storage, it's all sitting on one unit. I remember back to my grad school days, or PCs, like this is what we used to do, this is how we used to do our work, right? And then as the needs of organizations grow to better scale their storage, better manage their storage, two major new paradigms came in. So one is storage area networks, and the other is network-attached storage for file stores. And for storage area networks, the big difference there is the file system and the storage are separated over a network, right? So you're still running your application, maybe it's a database, it's running against a file system on your local machine, but the storage is remote from the computer, right? It's over a network to a SAN, which is providing high-performance block storage to serve that workload. The file system is doing all of the chatty work, and the conversation over to storage is in terms of these large block sizes, like 8K, 16K block sizes over the network. And then the storage layer is giving you, more control and configurability over who can access what data, performance, and scaling, and sort of much more of the kind of storage management aspects that you might want to think about as your organization scaling and growing a range and managing a range of different workloads. And then the other major paradigm that was very prevalent for a long time is obviously just file shares. So this is, I need somewhere to store my files for content for my organization. I create a file share. All those individual machines connect over the network to a file share for document sharing, right? And here the application is sitting in the machine, and the file system and the locking and control of that is all being handled across the network to the file share and the file system. And then fairly recently, so maybe about a decade or so ago, a new class of storage system emerged for object storage. And so this is the use case where, it's more digital media companies, large amounts of backups, like the capabilities of file storage systems and SANs were kind of overpowered for a use case of, I just want to store a really large amount of data really cheaply. So this idea of object storage emerged, where I want to store a large amount of data over the network. It had a different API, different semantics, and actually this really took off probably in the cloud first, but there's been on-premises and still are on-premises products for that for a very long time. So these are sort of the major evolutions of the storage landscape. And then if I translate that to Google Cloud Platform, and I'll go through these in a little bit more detail. So for block storage, either direct attached storage or the equivalent of a SAN, then our products are local SSD for persistent storage. So if you want a persistent volume, a disk that you can attach to a VM, persistent disk is the product that we have for that. Comes in two flavors, standard and SSD. That's persistent across VM restarts. And then there's local SSD, which is ephemeral storage that only lives as long as the VM. For network-attached storage, we launched, I think it's just earlier this year, product CloudFirestore to GA, which provides you network-attached storage, so you can create and mount a file share for your applications. So that's a first-party service. We recently, earlier this year, announced we acquired a company called Elastifile, which will give us much more scale capabilities as well as much deeper enterprise feature set. So look out for more of that coming soon. And then in this area, we've also partnered with a number of the major file providers who many of you are probably using if you're using on-premise products today, like NetApp and Dell EMC. So that's the file offerings. And then for object storage, we have a product called Google Cloud Storage, which is our object storage equivalent in the cloud. OK, so that's storage. Databases. So this one's a little bit more complicated. So actually, for probably 30 years, from like the late 60s, 70s, right through the early 2000s, the world of databases and data warehouse was quote-unquote easy, right? You loaded up your transactions into a transactional database. That would be, at the time, you'd be looking at Oracle, IBM were the two major vendors. Microsoft came along later with SQL Server. And you'd load up, that would be your main transaction processing system. If you needed more horsepower and more juice, you just keep scaling up the box and buy your HP Superdome and just keep piling more iron behind it and racking up the performance and throwing more memory in. But that's how you built large-scale transactional processing systems. And then when you wanted to run reports on them, well, that was bad. Don't do that. Don't run reports against your main transactional system. So you'd pull data off and put it into a warehouse. And this would be data that you would know the type of questions you want to ask. You know the schema that you are going to ask the question on. It's running reports, very kind of structured, classic BI. And you would pull data off from your database. You'd reshape it with a star schema, do columnar indexes and things to make performance fast, and you'd load the data into a warehouse. And then, for 30 years, the industry was good and happy with this, right? Transactions here, ETL over here, Informatica et al., into warehouse, job done, everybody's happy. And then around about 10, 20 years ago, the world kind of got a little crazier. The amount of data that was getting generated and the types of insights that people wanted to get out of the data and the number of people who wanted to be able to get insights out of the data to sort of better optimize their business just really ballooned. And the traditional database, data warehouse ecosystem just wasn't really well suited for that. So a whole range of new processing engines started to evolve. One of the first of which was, actually came out of, the original idea and papers came out of Google many years ago, was the whole area of sort of Hadoop and MapReduce, right? And the idea here is just capture all of your raw data. So, capturing search logs, just dump mountains of raw data into really cheap storage, and then disaggregate compute from storage so that when I want to run analytics jobs over it, I can create very simple jobs to scan my data and refine it, and just keep doing that at scale, right? And so the Hadoop ecosystem kind of evolved out of that need to manage large amounts of unstructured storage and get insights out of it. Now, that ecosystem has steadily, over time, started to add richer and richer capabilities, starting to think about richer metadata, and being able to manage that, being able to get better security over it, and more governance. So that ecosystem continues to evolve. And then on more of the structured side, two of the big dynamics here in terms of the shapes and scale of which you might want to deal with data came about. So there's a set of use cases where if I just have like really, really large amounts of very sparse columns, right? So I'm just spitting out records from gaming systems or from cell towers, and the data it's structured, but it's like a really wide column, but kind of very sparsely populated. That's a thing also that traditional database systems, you could twist and force the data into them, but at really, really big scale, some of the trade-offs and the sort of really powerful capabilities and the ACID transactions of databases are sometimes a little bit overkill. So people were willing to make these compromises of things like eventual consistency to get the scale and replication that they wanted and be able to operate at super, super high scale. So a set of databases emerged around the key value space. Similarly for documents, so document databases like dealing with like JSON documents, semi-structured formats where people want to be able to capture that data and then still query it effectively. That led to another class of databases. And then, of course, now we're also looking at being able to sort of break some of the paradigms of these sort of scale-up databases with the way that people dealt with transaction processing at scale, right? There's only one other real scale-out, high availability option in the market from the traditional vendors. And then Google has now really innovated with really scale-out transactional processing for RDBMS, which is a really hard problem to get into. You're into the cap theorem and making trade-offs that Google's done some super interesting innovation with atomic clocks to kind of work with. And that's the final column here. So if you go through now the sort of the Google options here, we have the classic databases with sort of Cloud SQL, MySQL for Postgres, and a later, we were missing the latest update there, which is SQL Server that was just announced. BigQuery for data warehouse. For data lakes and big data processing, this is Cloud Data Proc, which is our managed Hadoop service, and Google Cloud Storage, the object storage I just talked about previously. Cloud BigTable for key value, Firestore for hierarchical, so JSON documents, and then Cloud Spanner for like really global transaction processing. So that's sort of the brief overall journey of how the industry has evolved from storage and databases, and then what are the equivalent offerings that you might map to as you think about Google Cloud. And this is kind of just a quick summary of all of that together. All right, let me dive in a little bit and spend maybe 5-10 minutes just on the storage offerings in particular and go through some of the use cases that we see most prevalent there and how our products fit in to support that. So Google Cloud Storage. So as I said earlier, sort of object storage is something that really took off in the cloud, right? For a number of really interesting use cases, right? And the sort of the big three use cases that we see for GCS, content storage and delivery, large-scale batch processing and analytics, and then long-term data retention and archival, right? So content storage and delivery. So where Google Cloud Storage originally came from is that we took some of Google's amazing global products that we were using internally and then shaped them for the enterprise customer in Google Cloud Platform. And where this product originally came from was storing attachments for Gmail and serving them globally around the world, right? So under the covers, we're using the same kind of technology that we use for the rest of Google. So Google Cloud Storage has this amazing ability to bring data into the platform, store it, and then serve it and edge cache it out to customers globally. So it isn't just a regional storage product. It has a lot of networking capabilities built in to accelerate transfers into GCP, store the data redundantly, and then serve that content out with edge caching to end users. Now, you can also use CDNs and other things to manage how you distribute content, but for just basic, simple storage loading, storage, and delivery, we have like an end-to-end solution for content storage and delivery kind of built in as part of GCS. Super powerful for that. Big data analytics processing. So in this use case, you're really wanting to, like the Hadoop use case I was talking about, you want to store your data in a regional bucket, use HDFS, our HDFS connector, to operate over that data. And we give you really great performance characteristics and something called strong list consistency, which I'll come back to in a minute. And then the final use case, sort of archival, just really large amounts of low-cost archival. So some key features here. So fully managed with SLA. You can choose different SLAs depending on the locations in which you want to store your data. We offer the only product in the industry that gives you tiering from standard through nearline, cold line, and then an archive tier coming soon, where you can take your data from hot and tier it down to the coldest form of data for cheaper storage. You pay more to access it, but cheaper storage. And a really interesting thing about this product is even in the coldest tier, you get the same access pattern performance to that data. So millisecond access to even your archive data, right, which no one else has. You don't have to stage your data back or do anything complicated. Single API, same performance against all storage classes. You just pay for how you access the data. So that's super powerful. All the data is encrypted by default in GCS, so you don't need to do anything, and we encrypt your data automatically. If you wanted to have richer security and management controls, you can do that with various key management. And then I'll hit this one at the end last, strong list consistency. So this is a little geeky, but I kind of love it because it's very cool. With GCS, when you write objects in, as soon as we acknowledge that write of the object, that object is immediately available for all clients to read that data. It might not sound like a particularly challenging thing, but when you're operating in a dual region or a multi-regional bucket where data is spread geographically across sometimes countries, then it's actually quite challenging to do this. And strong list consistency is super, super important for workloads like the big data workload that I was talking about, where you have multiple compute instances reading and writing to the same data set. If they're seeing different views of the data, it can get super, super complicated. So we use Spanner, the product I talked about, with that really powerful global database that Google has released. We use that internally for all of our metadata for GCS. So super powerful product. Gives a lot of power for a number of those use cases that I talked about. One of our big goals for storage is actually to make storage really simple and easy to use, right? So want to have as few configurations and complexity as possible and just make the product simple and easy to use and really great for the different use cases that customers have. All right, persistent disk. So this is block storage attached to GCE VMs. Two flavors of it, standard and high-performance SSD. Don't need to stripe your disks to get the best performance. Over the last year, we've released a number of performance enhancements that have just rolled out without us changing the price. So we've increased the IOPS to up to 100,000 read IOPS from 60,000 IOPS. We've improved throughput to 1.2 gig from 240 meg across a number of our offerings. And we've increased the maximum size that you can attach to a disk. So our philosophy here is let's just keep bringing improvements without introducing more complexity and choice as how you take advantage of them. And one other thing I want to hit here at the end, snapshots, yeah. So with disks, attach disks to VMs, and then we have the ability to snapshot your disks both on a schedule and out into other regions where they're stored as backups in GCS. And then for customers who have super high availability needs, we have the only product in the industry in the clouds, the public cloud providers, of regional PD. So this is, I can choose 2 zones within a region, and we'll synchronously replicate the data between those 2 zones. So if you're building, or if you need to build high availability, typically a database on top of that, this is a feature that lets you get really powerful capabilities in terms of RPO and RTO characteristics for your most demanding applications. CloudFirestore, so another fully managed service. This provides a network-attached file storage product. We have, again, keep it nice and simple, 2 performance tiers, standard, high performance. It's super easy to use. We've focused on making it easy to use from both GCE and GKE. You'll expect to see more from us, more announcements next year as we start to bring some of the Elastifile capabilities for scale and for enterprise features coming in this area. Super common use cases for this, file shares, content sharing, also used for HPC and batch compute. So if you're running a large HPC job, then often those applications have been written against, a POSIX file system. That's been the traditional way that it's done on premises. And so sometimes customers might rewrite that to object storage, but often they just want to keep their application the same. And so having something with those nice, consistent APIs and semantics is key. So that's CloudFirestore for you. And then one other service I want to talk about a little bit is so I've talked about where to store your data in the cloud, but not necessarily how to get your data there. So we have a range of products for that. 2 on the large-scale storage side. There's others for data integration and BigQuery, but on just the sort of the large bulk move side of things, 2 big products, transfer appliance and transfer service. If I need to move a large amount of data from on-premises to the cloud, 2 big options. We can ship you an appliance. You can plug it in and then move your data to the appliance and FedEx it back to us. And we just announced this week, transfer service for on-premises, a software service that you can deploy an agent on-premises, and we will use that agent to move up to petabytes of data, taking care of network throttling, restarts, etc. Normally, you'd be writing tons of scripts and dealing with monitoring and managing them and all kinds of horrible things. So now we just have a super simple agent you can deploy, and it'll take care of the rest for you. So this is, for when you're looking at petabyte moves, these are a couple of services that we have for that. From the partner side, so I talked a little bit about sort of NetApp and Dell EMC as file products, so you can create NetApp cloud volumes on GCP. They're integrated from a product experience point of view, billing experience, similarly with Dell EMC. And then for a lot of the data protection partners, we're deeply integrated with them so that you can continue to use backup and data protection products that you're used to using on premises and just use them very simply and easily with the cloud. Again, this idea of make it easy, make it simple to use storage. And with that, I shall hand over to Penny, who shall walk us through the world of databases.
All right. Thank you, Dave. So like Dave, you might notice I'm from around these parts, but I can assure you I have flown in from San Francisco. So I'm the product lead for databases. I've been in San Francisco for the last 22 years. I wanted to run you through the database options here at Google Cloud and show you a quick demo. First off, in terms of kind of an overview of the options, we have both database services fully managed by Google here on the left-hand side, and I'm going to get into these in more detail, but roughly speaking, they break down into what we call cloud-native services, and then compatible services with OSS and proprietary databases. But the other thing that I wanted to speak about specifically on this slide, because I won't have any more drill downs on this, are some other options. The first is that we actually are partnering with a lot of the open source vendors. We call this kind of third party as a first party offering. So the likes of MongoDB, Redis Labs, Confluent, DataStax, they are running on GCE. They're offering a managed services, but with integrated billing. And some of these also offer integrated console and integrated support. So if you just want to lift and shift these open source databases as is, that is one option for you, and you will get integrated billing and a certain level of integrated support as well. The other option, of course, is that you can run the databases yourself. You can manage them yourself on our infrastructure. So pretty much, that means you can run any database you want on Google Cloud Compute Engine. The one I did want to pull out here, because this database at the moment we can't run as a managed service, is Oracle. And so if you heard the announcements over the last 2 days, we now have an offering to manage the Oracle database on bare metal. So we have a bare metal solution which constrains the Oracle license, and we can offer you Oracle right next to GCP. So they're the kind of third-party and proprietary databases we can offer. But now I wanted to drill down onto the databases that Google Cloud manages for you. And the first one I want to talk about is Cloud SQL. Cloud SQL is incredibly popular in terms of the number of customers running on Cloud SQL. What is this good for? This is good for if you're running MySQL or Postgres today, and soon you'll see also a possibility for SQL Server. The internal tagline for Cloud SQL is a database that takes care of itself. So in a couple of clicks, we will provision a database for you. It will be highly available. Thank you, Dave, for replicated persistent disk. We will manage the backups for you. We will manage the upgrades for you. We will manage security. So you just want all of that operational burden off you, but you want a database that is compatible with MySQL, Postgres, and now SQL Server. This is the database for you. The one thing I would say about these databases is that although we take care of these databases for you, a lot of the customers, because of the nature of these databases, do want some level of control. And some of the recent features we've introduced are, for example, customer-managed encryption keys. Similar to the disks, these databases that we manage, all of the data is encrypted by default. As of this week with Cloud SQL, we are allowing customers to manage the encryption key if they want to do so themselves. Otherwise, you can just let us manage the key, and we will encrypt the data for you. Some other interesting areas that you're going to see announcements coming soon is areas in the enhancements in areas like maintenance windows. So although we upgrade these databases for you, with these databases, unfortunately, there might be some downtime when the database upgrades. We're working to reduce the downtime. We're about to allow our customers using Cloud SQL to control when that downtime happens. So that's the type of enhancements happening in Cloud SQL, and keep those maintenance windows in mind, because we're going to come back to that concept as we look at some of the other databases. But for now, we're pleased to announce SQL Server is now in beta. And Ori, product manager for SQL Server, can you give us a quick show of what this looks like?
Thanks, Penny.
I think we need to switch the screens.
Let me just wake up the machine first. We'll get this up and running and walk through it. So hi, everyone. My name is Ori Kashi. I'm a product manager on the Cloud SQL and Databases team, specifically looking after Cloud SQL for SQL Server, which we are very, very happy to announce is now in open beta. So you can go in, it's available to all customers, and you can go ahead and try it out yourselves. So I'll walk you through in 1 second. Let's see. Come on. Actually provisioning an instance, and then what that experience is going to be like, talk you through some of the features that are available. Sorry, give me 1 sec. And then we'll see. Come on. There we go. Great. So this, if you're familiar with it, is the console for Google Cloud Platform. We're actually going to go over to creating a SQL Server instance over here. And the nice thing about building into our managed portfolio of Cloud SQL is that we bring all of the same functionality that you've come to expect from our other database products. So with MySQL, with Postgres, that commonality extends even to proprietary databases like SQL Server. And so what does that mean? Certain functionality, like when we talk about high availability, is actually the same. So we're not using SQL Server's native always on in this case. That's something that we have a separate roadmap item for. This is actually using replicated persistent disk. And there are some benefits to that. So we do have storage level replication that's cross-region, but it happens at the storage layer. So you don't have those performance impacts. And you also don't need a secondary license for your other instance of SQL Server in this case. And if you're familiar with how you're already managing this for a Postgres instance, it's going to behave the exact same way when you talk about SQL Server. Additionally, we provide compatibility today to SQL Server 2017, 4 editions. So we have Express, Web, Standard, and Enterprise. And built on top of the same VMs that you should be able to access today as well for GCE, the compute engine. And so you can scale this up for, let's say, we can go to custom, a custom instance. And if we select Enterprise, you'll see the maximum. Today, go up to 64 cores and go up to 416 gigs. Now, as Dave mentioned, the investment that we're making is to continuously improve and push the boundaries of the resources that we make available. So if you have kept up, if you have noticed that compute engine has new family types, new machine types, things like that, those are all coming here as well. And those new limits of 96 core machines and higher limits on storage and all that, that's all something that we're going to make available on Cloud SQL as well. So if you are running large workloads, this is an option for you. This is something that can accommodate that level of resources as well. Now, beyond that, a little word about connectivity. This is a very common question that we get asked for Cloud SQL. So besides the private IP that you're able to, again, leverage the commonality across GCP, which is the versatile private network that you can go and create within GCP and then peer that across many resources, across many different services, alongside storage, compute, whatever else that you need. You can also have a public IP if you choose to expose. And there also is a Cloud SQL proxy, which is actually just a client-side connectivity tool, essentially, that you can deploy. And that'll give you a secure connection if you need to go from on-prem or another cloud provider or anywhere else, really, to connect to your Cloud SQL instance. So that's an option as well without exposing your resources over the public internet. And to what Penny was mentioning, just to demonstrate here, so we have automation of backups as one of the managed features that we provide. And so there's up to 7 automated backups that can occur on whatever schedule that you can go and specify. You can specify the business hours that this occurs. And then, in addition, you can have manual backups, as many as you want. And so the automated backups, the rolling 7 that's just kind of occurs on its own if you select this option. But if you do so choose to have kind of a longer-term archival of your Cloud SQL instances, you can absolutely set that up. It's very simple with either our APIs or scripting, or you can even trigger it through the console and go ahead and continue there. A little bit of a word kind of on what Penny mentioned in terms of control. And so there are some, we try to be as permissive as possible in terms of compatibility. So I can connect to this instance and show you that, hey, I can run a bunch of different T-SQL commands, a bunch of different tooling that you would come to expect. And so in the case of SQL Server, for example, I can go and fire up SQL Server Management Studio. I can go and fire up PowerShell. It'll all work as expected. We do restrict certain behaviors, though, for security reasons that would give you access to the underlying file system, since this is a managed service. However, whenever our customers do come to us with requirements that some settings do give them value, then shouldn't be precluded from kind of access, we'll build that in actually as an interface as well. And so if you're familiar with this, we can go ahead and there we go. This is actually exposure of a stored procedure for SP-configure. If you're familiar with that on SQL Server, you can go and actually set the behavior of a bunch of different advanced and administrative options on the database instance itself. And so we're constantly evolving access here in terms of any of the core functionality of even proprietary databases. We want to go ahead and answer that request. We do this as well with Postgres when we talk about kind of different Postgres extensions that we're constantly adding and revisiting depending on what our customers are requiring from us. Okay. And then final little bit about maintenance. So this is something that we have had a lot of questions about, so I'll just take a second to talk about that. Today you can specify when maintenance will occur. Again, as a managed service, it's something that we'll take care of in terms of doing upgrades, doing patches, security updates, things like that. And so you can select today the window when that's happening outside of your business hours. We are also enhancing that capability in the future when we talk about notifications, deferrals, things like that. So those features will be coming as well as we proceed to give you more control so that we don't interrupt your rhythm of business, even with a managed service. Okay, so just for the sake of completion, we can say demo 1, 2, 3, generate a password. I have full availability in all of the zones that we have today. I think we have 20 regions, each one about 3 to 4 zones. I'll actually go and create this in Europe. And great. And it's that simple to go ahead and actually create an instance. So this will be up in a minute or two. It'll spin up, and I can actually go ahead and connect to it. So in the interest of time, I'm going to hand it back to Penny so she can complete talking about our other database offerings. But you'll see kind of we walk through the quick flow, and you already have a managed instance up and running. Thank you.
Thank you, Ori. So as Ori said, this is currently in beta. So if anyone's interested, you can connect to your Google Cloud console right now and test this out yourself. If we could go back to the slides, please. All right. So just to start off on some of the other databases, Cloud Memory Store. So if you have an application that could benefit from a distributed cache over a low latency use case, Memory Store is the service. Memory Store is our managed Redis service. It offers a variety of Redis versions, and we will continue to update the versions it offers. With Memory Store, it's highly available naturally, but in addition, if you need some persistence for your application, you can back up the Redis using native RDB format for extra persistence. Redis is tightly integrated with Stackdriver, our alerting and monitoring interface, so you can always kind of keep an eye and check on how the Redis is performing. If anyone's used Redis in terms of the open source version, there are some challenges around the management and reliability of Redis. And what we've done here with our managed Redis service is we've enhanced the memory management, and we've put controls in to prevent any issues of out-of-memory conditions. It is fully open source protocol compatible, so you can literally lift and shift Redis from other cloud providers or on-prem today as is. So memory store is the managed caching service. Now I wanted to talk about Cloud Spanner. Dave has already mentioned Cloud Spanner. Any of you using Google services today, so Gmail, Photos, YouTube, all of those services rely on Spanner behind the scenes. Spanner is a unique database. It is the first database that is able to offer globally distributed transactions with strong consistency. So Cloud Spanner was launched externally approximately 2.5 years ago after many years of being developed inside Google and being battle tested underneath all of the Google applications. In terms of Cloud Spanner, this is a cloud-native database. It has the unique capabilities that we have geographically distributed transactions. It has also got a SQL interface, ANSI standard SQL. But in addition, because this is a cloud-native database, this truly not only takes care of itself, but it takes care of itself without you. And so while Ori and I talked about maintenance windows for the proprietary and the open source databases, there is no concept of maintenance windows with Cloud Spanner. We will update Cloud Spanner behind the scenes with no interruption to users. It will remain online. It will remain highly available. In terms of high availability, that's the other interesting thing to talk about Cloud Spanner. So Cloud Spanner offers 5 nines availability. Again, this is fairly unique in the industry. I should also mention about the 5 nines availability. In order to offer that, we deploy Spanner across regions. What we've recently done is actually lowered the entry cost of this 5 nines availability. So previously, you would have to deploy 3 Spanner nodes to get 5 nines. And about 2 months ago, we introduced single node SLA for Spanner. So if you looked at Spanner in the past and felt like the entry cost was too high, please come back. We have now reduced the entry cost for 5 nines availability of Spanner. We will be doing more work as we look towards next year in terms of further reducing the friction and cost of starting to use Spanner. Although the idea of these globally distributed transactions is very interesting and unique, there's another aspect to Spanner that a lot of customers find alluring, and that is scale insurance. So you can start with one node Spanner, but as your workload changes, you can scale online without any interruption. You can scale up, you can scale down. So if you're unsure of how much capacity you need, this is a great database for you. It's got a lot of popularity with industries such as gaming industries that are unsure how popular a game will be, and retail that has seasonal workloads. But a lot of other applications likewise would benefit from this ability to scale up, scale down, no downtime, everything remains online. The other thing I should say about Cloud Spanner is just this week we introduced support for Hibernate, the ORM tool against Cloud Spanner. And so we will be introducing more and more compatibility with the tools that you use today to use Spanner. Moving on to our NoSQL databases, I wanted to start with Cloud BigTable. So Cloud BigTable is a wide key value column store. It is fully managed database. It also offers multi-region replication that is under the user control managed by Google. The difference here between Cloud BigTable contrasting it to Spanner is that when you want multi-region replication with BigTable for availability reasons, we will do so asynchronously. And that enables Cloud BigTable to give extremely low latency performance. Cloud BigTable is designed for very good price performance at very high throughput, but it does come at the cost of consistency. So if you want a fully consistent database, Spanner is your answer. If you do not need consistency and you would rather get to extreme low latency transactions, Cloud BigTable may be the answer for you. It is a NoSQL database key value, so its typical use cases are when you're typically looking up on one key constantly or on a small range of values. The kind of industries we see Cloud BigTable being used are ad tech, streaming analytics. And in terms of the databases that a lot of customers are coming from, typically it's HBase and Cassandra. So if you run in HBase Cassandra today and have any challenges around management or scalability of those databases, Cloud BigTable is a big destination. We are fully HBase client compatible, and a lot of customers have moved from Cassandra to BigTable, and there's white papers and sample code available for you to make that move. Which leads me on to our other NoSQL database, CloudFirestore. So CloudFirestore is our fully managed document-style database. We introduced this just in January of this year, and it's had tremendous developer uptake. So we have hundreds of thousands of developers running on CloudFirestore today. CloudFirestore is extremely good if you want an easy-to-use back-end document-style database. Typically, it's used for website caching. It can be used for mobile-style applications as a back-end. In fact, CloudFirestore is the back-end database to Firebase. So if anyone's familiar with Firebase, the Android mobile-style database, this is the back-end synchronization for that database. The other thing to say about Firestore that's interesting is that it itself is built on Spanner. And so Firestore has ACID compliance inside it, but unlike Spanner, it is schemaless. So if you want a more flexible, schema-less style database, then Firestore may be appropriate for you. The other interesting thing about Firestore is it's serverless, and the pricing is based on operations. So you don't need to specify up front how much compute or storage you need. It will just scale up and down on demand, and you'll be, the cost will be based on the operations performed. They're kind of the array of what I would call operational databases, but I did want to also briefly mention BigQuery. So BigQuery is our analytical database used typically for enterprise data warehouses. So a lot of customers that want to move off the proprietary databases on-prem, such as Teradata and Oracle, are looking to move to BigQuery. BigQuery, like Spanner, has full standard SQL support. You can run joins. You can run analytical-style queries against BigQuery. It is serverless, again, so we can scale up, scale down on demand. The other interesting thing about BigQuery and a lot of our services is we're looking at offering enhanced integration between them. And so earlier this year, we announced federated query from BigQuery to Cloud SQL. So you don't have to move all of your data into BigQuery. You can use BigQuery as the analytical engine and reach outside of BigQuery, and we can naturally do that today to Cloud SQL as a source. So that's really given you an overview of our offerings today. Dave, thank you very much for the introduction to databases and the overview of storage. And you've seen the overview of the databases, both from cloud native and the open source and proprietary compatible databases. Do we have time for Q&A, Dave?
Sure. Well, 5 minutes.
Oh, I see. I didn't notice the clock.
There we go. Yeah. Any questions?
Hi, hello. I have two use cases. First one is we want to live stream dashcam data and also store them for later analytics. Second use case is to store GPS location. Yes.
So if I heard that right, so you want to live stream?
From dashcam.
From dashcam. So, OK, so streaming video data from cameras that how are they connected?
Yes, I mean, these days they call it connected camera.
OK, yep. And then GPS data as well.
GPS.
OK, so without knowing too much more about it, I suspect for the large amounts of unstructured data that you're going to want to bring in, then GCS, Google Cloud Storage, would be a great place to store large amounts of data at scale. I suspect the biggest challenge you're going to run into will be the network connectivity and the bandwidth that you need to get that data to the cloud, but assuming that you can, if you want to do that live, then you'll need to solve for that, and then stream it into the closest region that you have, wherever that may be, and then you might want to aggregate it and use various transfer jobs to move the data around the world for where you might want to do analytics over it, for example. And then for GPS data, you said? Yeah, a lot of that will depend on what you want to do with the GPS data. If you want to use it for analytics,
yeah, I mean, two purposes. One is for live location tracking,
okay,
right? And then for analytics, say, for example, where a vehicle is parked or where someone is.
Yeah. I mean, it might want to go into your operational database system or into the analytics system or both. Do you have any?
Without knowing more about the use case, it's difficult to say, but...
Yeah, I mean, I think we have a number of different options there, and it kind of depends. If it's going to be part of like an operational system that you have, then you might want to consider one of the more transactional databases. If it's just for like, I just need to get this data in as fast as possible, then some of the large serverless, maybe BigTable might be good for that kind of use case. And if it's just straight for analytics, then you could just actually stream the data straight into BigQuery as the warehouse. So, yeah. Oh yeah, okay. Aha.
Just to add to that, so if you do store the video data on Google Cloud Storage, we do have video streaming services that actually directly connect to that and then leverage our CDNs and everything else, depending where you're streaming them to. So there's a bunch of ML services and just the video streaming services that exist. And for geospatial data, if you do go the relational route, Postgres actually has a number of extensions as part of Cloud SQL that you can go and take a look at. We actually have a number of use cases for geospatial data in Postgres.
Question?
Hi. Cloud Spanner has quite a good story for the query language is SQL, right? But the data definition language, as I understand it, is not SQL. It's through a separate API. Is there some plan to change that so you can use standard SQL for defining your schemas?
No, I mean, I think it is standard and SQL for DDL as well.
Yeah. Really?
You can use the APIs though. So there are a number of specialized Spanner APIs for schema definition that can be used. The operations that you can use with Spanner, if I'm not mistaken, for SQL are limited. So I don't think you have the robustness of the traditional relational databases in the SQL statements that you can use. But you can make some changes as far as I'm aware.
Right.
But we can chat offline. I can double check for you after the session.
I think just right behind you.
Hi, can you tell a typical latencies for different types of storage options and databases? It was mentioned for some times in the presentation, but not for all of them. I would say the fastest one would be local persistent disks, right?
Yeah. So we'll start at the bottom of the stack and then work our way up, right? So block storage will give you the fastest, like, sort of millisecond latencies. Local SSD, the fastest of them all. It's locally attached, so that'll give you the lowest latency and highest IOPS. Persistent disk is next, again, still in milliseconds. Google Cloud Storage, you're now talking about 100 milliseconds, somewhere around there. Off the top of my head, I'm not sure what the Firestore latencies are, but they'll probably be somewhere in between that. And then we can keep going up the stack from there.
Yeah, with BigTable, we're, again, low single milliseconds. And kind of the span for the databases would then go up to Spanner, where, especially if we're doing cross-region writes, it gets into what, like 10 milliseconds or so?
Cross-region, yeah.
For the cross-region writes. Yes?
So what do you advise for the image sort of the data which is very heavy?
Images?
Yes. So the images generations and all, which is in the gigabytes and the terabytes of the images, what do you suggest in that context?
So for large amounts of unstructured data, so images is typically in that category. Google Cloud Storage would be the object storage service, would be normally what I would suggest customers to use, unless they're using it as part of something like a file share that they're already using, in which case Firestore. So if you need a POSIX interface over it, then that would be Firestore. We do have some things like GCS views that'll put something of a POSIX front end in front of GCS, but they have a whole range of limitations. So if you need POSIX, it's Firestore. And if you can work with something other than that, then Google Cloud Storage would be the way to go.
Question?
So last one, I guess, just with your object storage, you bring in data archive storage, but you said you don't need to stage it anymore. It'll be, or your competitor stages it, but you won't. So what kind of speeds are you thinking of in terms of retrieval?
Yeah, so the question was for the, I mentioned in the talk that the archival product is online and not offline, and that you don't need to stage from offline to online. So the question was, well, what are the access times in order to do that, to get to that? Exactly the same as all the rest of the storage classes. So 100 milliseconds. So it doesn't make any difference which storage class you use. We give you the same performance. The principle we wanted to maintain here is the management of your storage, whether from its location or its tier, should be something you could administer in the background without changing the performance of your application. That's a kind of really hard paradigm to maintain, but it's one we're trying to just, again, make it simple for customers to build their applications on without changing the back end for that.
All right.
Great.
Thank you very much for your time.
Thanks so much.
Yep, thank you.